Let's continue our discussion to 2D shapes. The first 2D shape we are going to discuss is the circle. Let's continue our discussion with 2D shapes. The first shape we have is a circle. A circle has a center and a radius. A key property of a circle is all points on the circumference of the circle will be the same distance from the center, which is the radius. Another important property of a circle is the diameter. The diameter is 2 times the radius, and it is the furthest distance 2 points can be on the circle. The perimeter of the circle is also called circumference. Can you tell me how many lines of symmetry does a circle have? Think about it. The answer is infinite lines. So each line which passes through the center is actually a line of symmetry. Let's discuss some special cases of circles. The first case is that of a clock. These cases are very important from an exam point of view. So let's look at a clock and what it represents. A clock is basically a full circle divided into 12 sections. Each section represents 1 hour of movement by the hour hand or 5 minutes by the minute hand. In terms of degrees, each section represents 360 by 12 is equal to 30 degrees. This is because overall the full circle is divided into 12 parts, and we know a full circle is 360 degrees, isn't it? So each section is 30 degrees. In terms of movement, in 1 hour, the minute hand moves a full 360 degrees because in 1 hour, the minute hand covers the whole circle. And the hour hand moves just 30 degrees. For example, from 2 to 3, that's 30 degrees in 1 hour. There will be a lot of questions based around this, and when we come down to the practice section, we'll have a lot of questions to do. But for now, let's move on to the special case 2, which is a compass. This is a photo of a compass. I'm sure you must have come across this during your studies. Here, the full circle is divided into 8 sections, that is north, south, east, west, the northeast, southeast, southwest, and northwest. Here, each section represents 360 by 8 is equal to 45 degrees. Coming to the next shape, which is a triangle. This is a triangle. A triangle is basically a polygon with 3 edges and 3 vertices. There are some important definitions regards triangles. Let's move on to those. We can categorize triangles based on sides. So a scalene triangle is a triangle where all the 3 sides are of different lengths. An isosceles triangle has 2 sides of similar length and 1 of different length. And the equilateral triangle has all 3 sides of the same length. Let's talk about isosceles triangle. Here, the 2 sides marked are of equal length, and the angles at the base of the equal sides are also going to be equal. So keep this property in mind. This might help you solve some questions. There is only one line of symmetry in an isosceles triangle, which is the one shown. An equilateral triangle, on the other hand, has all 3 sides equal, and all 3 internal angles are also going to be equal and exactly 60 degrees. There are going to be 3 lines of symmetry for an equilateral triangle, which are the ones which are shown in this image. Let's move on to classification of triangles based on the angles themselves. So we have a right angle triangle where one of the angles is 90 degrees, an acute angle triangle where all the 3 angles are less than 90 degrees, and an obtuse angle triangle where one of the angles is more than 90 degrees. So if you remember these basic definitions, it will be really good from an exam point of view. Properties of triangles. Sum of all the internal angles in a triangle will always be 180 degrees. So in case you are given 2 angles and you have to find out the third, just remember that sum of all 3 has to be 180. Parameter of a triangle is basically the sum of all the sides, and the area of the triangle is half into base into height. Uh, we can try to understand how this formula came about by taking an example. We'll take the example of a right angle triangle and illustrate this, but we can use this formula for other triangles as well. So here we have a right angle triangle, and let us say we double this triangle and put another one of a similar size and shape in an inverted manner like shown. This becomes a rectangle. And we know that the area of a rectangle is the sum of the two sides, so base into height. The triangle only covers half of this area of the rectangle. So the area of the triangle is half of base into height, which is the formula we discussed, half into base into height. So you can use this formula for all triangles and not just a right angle triangle. So remember this. Let's talk about a quadrilateral. A quadrilateral is a polygon with 4 sides and 4 vertices. Let's discuss some important quadrilateral types. First, we have a square. A square has 4 equal sides and 4 right angles. There are 2 pair of parallel sides, so the opposite sides are parallel, and there are 4 lines of symmetry as shown. Then we have a rectangle which has 2 pair of equal sides and 4 right angles, 2 pair of parallel sides, and 2 lines of symmetry. I know this is a lot of information to take in, but after the video, just pause this screen and try to understand what all of these things mean, and try to work out for yourself that you understand how many lines of symmetry, how many right angles, how many pair of parallel sides each figure has. And if you internalize it, it will really help you in the exam. Now, here we have a rhombus. A rhombus basically has 4 equal sides and the opposite angles are equal. There are 2 parallel sides and 2 lines of symmetry as shown. A parallelogram is this image. There are 2 equal sides, 2 pair of parallel sides, opposite sides are equal, but there is no line of symmetry. Trapezium has 1 pair of parallel sides. A kite has 2 pair of equal sides and 1 pair of equal angles. So the angles in the middle, which are the obtuse angles in this image, are going to be equal, and there is only 1 line of symmetry. So this is a very important point, and you might find a lot of questions around line of symmetry in the exam. It's worth remembering that rectangle, rhombus, and square are all special cases of a parallelogram. So the important thing in a parallelogram is that the opposite sides are parallel to each other. And so a rectangle, rhombus, and square are just special cases of a parallelogram. Sum of interior angles in a quadrilateral is always going to be 360 degrees. So in case you are given 3 of the angles and you have to find out the 4th, it's not going to be that difficult. Area of a parallelogram is base into height. So this formula can be used for all parallelograms, including rectangles, squares. So in a square and rectangle, we know it's the product of the sides anyways. So this is applicable to all parallelograms. Let's come on to some other important regular polygons. A pentagon has 5 equal sides, 5 lines of symmetry, and 5 equal internal angles. Similarly, a hexagon has 6 sides and 6 lines of symmetry as shown. Heptagon has 7 sides and 7 lines of symmetry. An octagon has 8 sides and 8 lines of symmetry. Nanogon 9 and decagon 10. In regular polygons, number of lines of symmetry is exactly equal to the number of sides. Let's go back to triangles. So a regular triangle is also known as an equilateral triangle, which has all sides equal. And if you remember, it had 3 lines of symmetry. Similarly, a square, which is essentially a regular quadrilateral, it has 4 lines of symmetry. And pentagon has 5, hexagon has 6, etc., etc. So in regular polygons, number of sides is equal to the number of lines of symmetry. Let's have a short break and do some practice questions before we move on to 3D shapes.